Shh. I'm recording. F of x plus h minus f of x all over h is what we're going to use right now. We're going to have to take the limit of it later on in the class, and the limit always is as h approaches 0, which is a problem. Because if I plug in 0 for h, what's it going to do? Error. My denominator is going to be 0. We have problems, right? So no matter what we have to do in order to do the limit as x approaches 0, which we're going to do later on, we're going to have to get that h to get out of our lives, because then we can plug in 0 and life is good, right? If we plug in 0 with that h in there, we actually go against all math work and math knowledge, and we get it's destroyed. Epic failure, you know? So say I give you f of x equals x squared, I'll give an easier one first, 3x plus 2. And I have to fill it into this formula. Well, I gave you f of x, so I can clearly put that in for f of x in the formula, right? So I'm going to have something with an equal sign running down, because this is an expression. This expression is going to equal the next expression, is going to equal the next expression, blah, blah, blah. So I have minus f of x, and this is where the common error happens. What did I not do? Yeah, I just minused the first term of f of x. I didn't minus f of x, right? So I have to make sure to minus f of x that I have a bracket. H is h, that stays. I should have left a little more space at the beginning. You'll see why in a second. Now I need to find out what the heck f of x plus h is. If I gave you f of 2, you would put 2 in for the x's. If I gave you f of a, you would put a in for the x's. If I gave you f of smiley face, you would put smiley face in for the x's. So if I give you f of x plus h, what are we going to do? X plus h in for the x's. So I'm going to do it off to the side, because if I do it into this formula, it's a whole bunch of work inside an ugly fraction. So what I do off to the side, I do f of x plus h off to the side and simplify it first, then put it back in. So I'm going to get, instead of x squared, I'm going to get x plus h squared minus 3x plus h plus 2. Whenever we have something a binomial squared, what I tell you should always do? Rewrite it. Rewrite it. Cross off that 2 and rewrite it out to us. So we would get x plus h times x plus h, so that we get that middle term. If not, a lot of people will tell me it's x squared plus h squared, which it is not. Distribute through, minus 3x minus 3h plus 2, and then we have to distribute. If there was a number in front of this, like 2x squared, I would leave the 2 sit out front, and I'd still FOIL the x plus h first, then put the 2 in. So I'm going to get x squared plus xh is plus 2xh plus h squared minus 3x minus 3h plus 2. Is there any terms that are like terms? No. So it's as good as it gets, so I can put it in here. So I get x squared plus 2xh plus h squared, like I said, I didn't give enough room, minus 3x minus 3h plus 2. And then our next step is to distribute that through, so we get x squared plus 2xh plus h squared minus 3x minus 3h plus 2 minus x squared plus 3x minus 2 all over h. 1 o'clock. That's when I get to start classes. All right. We need the h to get out of our lives, right? The h needs to cancel off somehow and get out of our lives. The only way it can is if we have an h in the numerator that can cancel off with it, correct? So whenever we use this formula with a polynomial, every term that doesn't have an h in it should cancel off at this point. If it doesn't, you made an oopsie. All right? So this one doesn't have an h. X squared cancels off with negative x squared. This has an h, this has an h. Negative 3x cancels off with 3x. Positive 2 cancels off with negative 2. Now, why do I just want terms with only h's left? Then I can take a GCF of an h out. The h's cancel off, and our life is good. We don't know that our life is good technically because I don't have a limit as h approaches 0, but if I do that, then we'll be able to plug in life will be good. So we can take an h out. We'll be left with 2x plus h minus 3 all over h. The h's cancel. And I'm left with 2x plus h minus 3. And that's a simplified form of that. Okay? I'm going to have you try the same thing, but this time f of x equals negative 3x squared plus 6x minus 4. Go. Then we're going to do radical, then we're going to do radical. I'm going to record it as I'm going along, but you guys are going to do it without looking up here. Then you'll check and see if you got it. All right, so anything without an h should be canceling off. If it doesn't cancel off, question yourself. You made an oopsie. More often than not, the oopsie is you didn't actually get 3 terms from the x plus h. You gave x squared plus h squared, and there's your issue. Or the other oopsie happens in forgetting to distribute that minus sign through, and then they're all the opposite sign of what you need them to be, the last two, and they don't cancel off. All right, so we take an h out. And we're left with negative 6x minus 3h plus 6 all over h. And so you're left with negative 6x minus 3h plus 6. All right, the next function I'm giving you, I'm only giving you a hint. I'm going to give you a radical function. And my hint is that you're going to have to multiply by the conjugate at some point to rationalize the numerator, not the denominator, which you're so much forced to do. Sometimes we rationalize numerators. Okay, so this is your function. F of x equals square root 2x plus 6. Go. And I want that format. So the previous example, plugging in the x plus h is actually complicated. You actually have to plug the x plus h in. You have to FOIL it or distribute it. You have to put in your coefficient, collect like terms, all that jazz, right? It's actually, that is complicated, putting in the x plus h. That is not the complicated part of this one. Remember I told you that the h's have to cancel. That's the goal, because we're going to put the limit as h approaches 0 on these. And once you get that h to cancel off, we'll be able to plug the 0 back in. So that's going to be our goal here. So f of x plus h is literally just, it just equals the square root of 2x plus h plus 6 which is just the square root of 2x plus 2h plus 6. That is not the riveting part of this. Okay, that's not like the crazy. This is the hardest part. Like, that's not it for this one. It's going to be multiplied by the conjugate. Now, we have to go f of x plus h, so that's the square root of 2x plus 2h plus 6. And then we're going to subtract off f of x, which is 2x plus 6. And it's all over h. And I told you, these are going to lead to the limit as h approaches 0. So we need to get that h to go away. Here's where the error happens on the test, guys. Everyone paying attention, because I know this is where you're going to mess up. If you do remember to multiply by the conjugate, that's a good thing. But then it's in the next step that people mess up. So here, we multiply by square root 2x plus 2h plus 6 minus the square root of 2x plus 6. Yep, that is a plus sign. I have no idea what you're talking about. 2x plus, it's even the same color, like it was there the whole time. 2h plus 6 plus. Now, the reason why we were taught to multiply by the conjugate in grade 11, which is when we started being taught to multiply by the conjugate, and it was to rationalize the denominator then. You realize that we can rationalize numerators or denominators. The reason why is those middle terms go away, and rationalizing means radicals are only left. The radicals are gone, and only numbers are left. Okay? If after you multiply by a conjugate of a radical, and you still have radicals, you oopsied. That's the point of multiplying by a conjugate is to get rid of the radicals. So if you still have some, you're wrong. Okay? Okay. So, we multiply coefficient times coefficient. Now remember, if I go root x times root x, the answer is x. Root 64 times root 64 would be 64. It's not like we have to actually find out what that is. So if I go root 2x plus 2h plus 6 times root 2x plus 2h plus 6, I just get 2x plus 2h plus 6. Okay. Then, if I go root 2x plus 2h plus 6 times root 2x plus 6, I would get root 2x 2h plus 6 in brackets and under the radical, and 2x plus 6 in brackets. Positive. Then in the middle, I would get negative that. What happens to them? Cancel. They cancel. That's a good thing. If they didn't, you would have had a minus sign here and we'd be in trouble. But I didn't, because I always had a plus sign the whole time. So I was totally fine the whole time. I wasn't, but it's okay. I would have caught myself. Now, negative root 2x plus 6 times 2x plus 6, I get minus 2x plus 6. So what do I have to remember to do? Minus 2x minus 6. There's the error that's going to happen. Okay? It's forgetting to distribute the minus sign through both of them. And this is the other error. People will distribute the x through. You've been taught to distribute in massive amounts in grade 10. Like it was like polynomial distribution 101. You just like distributed for days in that unit. So you guys have a distributing like complex. Like when you see something, you're like, I must distribute. Like it's bored into your soul at this time. Okay? We need that h to get out of our lives. We agree? So I need to cancel that h off. If I distribute it into a term, is it easy to cancel it off then? No. So what I always tell people to remember is you multiply the conjugates and you leave the ones that aren't conjugates apart, because I just write h because I want it to cancel off with something, and then I just rewrite this one. 2x plus 2h minus, or plus 6 plus root 2x plus 6. And I don't distribute it, because if I distribute the h in, it's a lot harder to cancel it, correct? Once again, everything without an h needs to get out of my life in the top, because I need to be able to cancel an h off. We agree? In the numerator, I'm left with a 2h. What can I just do now? This h can cancel off this one. If I have it embedded in there, people will just get stuck here. They're like, I don't know what to do, Mrs. Lepp. I can't get the h's to cancel. Because you will have went h this plus h that, right? So if you distribute it in, everyone's stuck here. If you don't distribute it in, people can cancel off, and often we'll get it correct. So we get 2. Now remember, if the 6's didn't cancel, think, what did I mess up? Because they should. And then be like, I need to distribute the minus sign through. Okay? Because we need to only have h's stuff with h's left. So now we're left with 2 over root 2x plus 2h plus 6 plus root 2x plus 6. And now a lot of you guys will go back and try and rationalize this, because it has been embedded into your soul again to rationalize denominators. Remember, this will be the limit as x approaches, or h approaches 0. So at this point, I can just put zeros in, correct? And I would be golden. I could go on because I wouldn't end up with a 0 in my denominator. So you're done. Don't go rationalizing. Don't be crazy. Stop it. Don't be crazy. All right. Last one to try, and then we're going to our notes. Go. Ready to record. Do we need to distribute the denominators? No. Your only goal in this, because I told you right now that this is going to be the limit as h approaches 0. Your only goal is to get the h out of your life. It is what is destroying this question. You will not be able to plug it in. So you do not need to distribute those denominators. If you want to, if it makes your heart sing to distribute them, go ahead. But it actually makes it longer, because the moment we plug a 0 in for h, you're going to get x plus 3 squared. You'll get 2x plus 3's. That h will cancel that, the 0 will cancel that h out. You'll get x plus 3 squared. You don't have to actually factor. All right. So the top, because these are ones, are a lot easier. So we get x plus 3 minus x minus h minus 3, because when I distribute a 1 in, it does diddly squat. Distribute a negative 1 in, helpful. The bottom is x plus h plus 3 plus x plus 3 divided by h, or what can I say? Multiplied by 1 over h. And I am allowed to flip it and multiply because the top was a full fraction, right? We're only allowed to flip when we have full fractions. Can you stack them and know that they cancel as well? Sure. I don't care how you know that the mathematics happens, but a lot of people like flipping it and seeing it actually over there so you can physically cancel. Okay? As long as it's legal math, I'm okay with it. X minus x, 3 minus 3. Now we have a negative h sitting here. Can that h cancel off that one? Did distributing this denominator was it helpful in any way? No. You just made more work for yourself. So this would be a minus 1 sitting here, correct? That one's gone. I have equal signs running down the left-hand side, and props comment on how much you guys don't know where the heck equal signs should be, and you just randomly put them there, or they don't exist, or you use arrows where equal signs could be. Okay? So this is an expression. It is not an equation. An equation has an equal sign in it to begin with. When you look at the question, it literally has a left side and a right side and an equal sign in it. That is an equation. When it doesn't have an equal sign in it, it is an expression. And the moment you are simplifying an expression, you should have an equal sign. Like this equals this next step would equal my next step, correct? Because they are expressions, they are equal to each other when you simplify. You could do something to undo them and go back to what you had before. Every single step, if you plug something in for x, would result in the same answer. Therefore, you put equal sign, right? Like if I plugged an x into this first step and an a 2 for this x and a 2 for this x and a 2 for the next one, I would get the same answers because they are actually the same thing, just written a little different. All right. My goal is when a prop sees my kids, who they wouldn't know you were my kids, they would know that, wow, these kids actually know where to put an equal sign. These kids were properly taught. That's my goal for you. Okay? When you see proper math on a page, written neatly on a page, you will mark it nicer. I'm sorry. If they're marking 300 kids' tests, they're not searching to give you marks. They're not going to be like, oh, over here, I see that they possibly did something correct. Maybe I should give them 0.5. Like, they're not. So if you are sequentially writing stuff in order, even if it isn't the most neat thing, but it's in a sequential order, they can read your numbers, and you have equal signs, man. They might search a little longer to get you more marks, okay? Because they don't have to search. It's in an order. He writes neatly and in an order. He just writes large. It's totally fine. I would take that in a heartbeat. Seriously. Let's go. Yeah. It's when you start writing in a pattern of like over here and the right, and then or over here and left, and then here, and then up here, and you're like just trying to find arrows. And then there's arrows. There's not even equal signs, or no equal sign to be found. Like you have to search long and hard for an equal sign on a page. That makes me sad. Okay, there should be equal signs. So, on the top we have -1. On the bottom we have x plus h plus 3. X plus 3. Now, guys, why did I say that you don't need to distribute? Because we're going to plug a 0 in for h at this point, right? When we do the limit, this is going to become x plus 3 times x plus 3, which is just x plus 3 squared. That's all it is. And some people will say, well, it's more simple if I go x squared plus 6x plus 9. No, it's not actually. You expanded it. You didn't simplify, you expanded. You did the opposite of simplify. Okay? So that's why we don't. Okay? So we're going to go to our notes. I'm in our notes. I forgot it. Okay, so the laws today that we're going to go over, you're going to be like, wow, these are just sensical. Like, why are we even going through these? This is stupid. We are, because sometimes even... Did you just throw your pencil?
I nearly fell off my chair.
It looked like your pencil was attacking you, though you
I
tossed
nearly
it.
fell off my chair.
Ah. It's sneaky. Okay, so we're going through all the limit laws, and we're going to pay attention. So, in section 1.1, we use a numerical approach, tables, and a graphical approach to investigate limits. This approach is not always reliable and sometimes very tedious. 1, find the limit of a sum, a difference, and a product. Many functions are combinations of sums, difference, and products. Sums, addition, differences, subtraction, products, multiplication of a constant function in the identity function. The following properties can be used to find the limit of such functions. The reason why I'm going through every single one of these is you need to be able to see theorems and not be overwhelmed, because they are overwhelming sounding. And I didn't know that when I went to university and I got overwhelmed. I want you in the same boat. So a theorem is just something that they state. It's a general theorem. That means it will work for every single thing. You guys want to see an example and say, this example means it works for everything. That's not how a theorem works. So a theorem, the limit of a sum. If f and g are functions for which the limit as x approaches c of f of x, and the limit as x approaches c of g of x both exist, that means that for function f, function g, the limit at that value exists. Okay, so it's continuous. From the left to the right, it's the same in both spots. Then the limit as x approaches c of f of x plus g of x exists. So, which makes sense. If the limit for f exists at that value, g exists at that value, when I add them, it exists at that value. And the limit as x approaches c of f of x plus g of x just equals the limit as x approaches c of f of x plus the limit as x approaches c of g of x. In words, the limit of a sum of two functions equals the sum of their limits. Sounds confusing. Literally just means if there's a limit at x here and a limit at 4, I can just go the limit as x approaches negative 3 and split them of x plus the limit as x approaches negative 3 of 4. And do them separately. Now remember, unless you plugging in that value creates a problem, your denominator becomes 0, or the numerator and denominator both 0 and cancel. So basically, if your denominator becomes 0 by plugging in the limit, you got to do something else. If you can directly substitute it in and it doesn't cause a denominator of 0, you can directly substitute. So, the limit as x approaches negative 3 of x would just be negative 3. I can substitute it in, correct? Does that cause me any problems? Do I have a 0 in my denominator by plugging that negative 3 in for x? No. Golden. The limit as x approaches negative 3 of 4. 4 is a line, a horizontal line at y equals 4. What's the value of y always going to be? 4. So when you take the limit of a constant function, it is what that value is. Because at negative 3, it's going to be 4. At 7, it's going to be 4. At positive infinity, it's going to be 4. At negative infinity, it's going to be 4. It's a horizontal line at 4, right? So it's just going to be plus 4. And so we get 1. Done. So what does that mean? That means I have a line. It is x plus 4, correct? At negative 3, what's its value going to be? 1. So we have the line at x plus 4. At negative 3, its y value is going to be 1. But the limit actually doesn't matter what it is at that value. What does the limit say? So if I'm asking you the limit as x approaches negative 3, I'm saying from the left, and from the right, it's approaching 1. We agree? Because this is a continuous function, the value at this actual equation is actually 1 as well, because it's a constant, or a continuous function, not a constant. So could I have just plugged negative 3 right into there? Yeah. Would I have had to show that I can add these up? No. But that's what the theorem says. And because that theorem exists, we can just plug it in. So we could have just went the limit as x approaches negative 3 is x plus 4, equals negative 3 plus 4, which is 1. So we could just plug it in. So, theorem, limit of a difference. If f and g are functions for which the limit as x approaches c of f of x and limit as x approaches c of g of x both exist, then the limit as x approaches c of f of x minus g of x exists. And the limit as x approaches c of f of x minus g of x could be rewritten as limit as x approaches c of f of x minus the limit as x approaches c of g of x. In words, the limit of the difference of two functions equals the difference of their limits. So, I could just fill this one in, because if I fill it in, it doesn't cause me problems, correct? I could just go the limit as x approaches 4 of 6 minus x, and then say, okay, well, that's going to be 6 minus 4. The moment, you guys, honestly, everyone paying attention, you guys don't know when you can drop off limits. So sometimes you keep the limit, you ditch the limit, you don't know when the heck there should be a limit gone. So sometimes people write limits when you shouldn't have limits. The limit is the value that you need to substitute in, correct? That's how I or you show what I need to substitute in for x. We agree? So the moment you substitute it in, the limit is gone. You don't write limit anymore. So here, I still haven't substituted the 4 in for x in this step here, correct? So I still have the limit there. The moment I substituted in, what happened?
The limit went away.
The limit went away. That's it. That's as easy as it is. The moment you substitute it in, the limit's not there anymore because the limit was there to tell you what to substitute in. So my answer is 2. So what does this mean? This means on the line 6 minus x. If I approach x equals 4 from the left and x equals 4 from the right, it's actually approaching 2. We agree?
Yeah.
Because it's a continuous function, we also know that f of 4 is 2. Because from the left and the right it's approaching 2, and at the value it's 2. We could also write this as the limit as x approaches 4 of 6. You guys are talking too much today. Minus the limit as x approaches 4 of negative x. Not negative x because the subtraction sign goes between them. If you pick negative x as the part that you're going to put in there, you'd have to have an addition sign between them. And so we get 6, because limit as x approaches 4 of a horizontal line at 6 is 6. And then this would be minus 4, which is 2. Same theorem happens for products. If I have two functions that are multiplied together, I can separate them out as two functions being multiplied. And now some people will say here, well, x squared, that would be the same as saying the limit as x approaches 3 of x times x. And then I could technically write them out separately. I could go the limit as x approaches 3 of x times the limit as x approaches 3 of x. And then in the next step, I would substitute in, so the limit would go away. We agree? So I'm going to put the 3 in for the x. I'm going to get 3 times 3. Then the limit is gone, and I write 9. Conversely, instead of doing it that way, I could have just filled it in right away, couldn't I? Because I don't have a problem. If I have a problem, if the denominator is 0 when I plug it in, I cannot just fill it in. So, this one, if I plug in negative 5, would it cause me a problem? No. So my next step, I could directly just plug it in. I can go negative 4 times negative 5. The moment I plug in that negative 5, the limit goes away, and I get an answer of 20. Okay? Then we're going to flip it over. So this is a corollary. A corollary is like a little add-on to a theorem. Do you think he's holding it there because he just wants to hold his nose, or do you think he has a bleeding? Is your nose bleeding?
Dying for attention.
Okay. If g is a function for which the limit as x approaches c of g of x exists, and if k is any real number, then we could technically take the k and we can completely bring it outside of the limit and then do the limit of just the function. That's a corollary. So we could technically take this 2, completely bring it outside and do the limit of what's left over. That's what the corollary is stating. No one is going to do that, just so you know. It's supposed to be an eraser. Thanks for not working. All right. what you guys will do is you're not going to be like, oh, the corollary says I can take the 2 out. You're going to say, if I plug in 1, is it going to cause me a problem? No. So you're just going to plug in 1. So the moment we plug in 1, the limit goes away. So I'm going to get 2 times 1, and then 1 plus 4. So I'm going to get 2 times what? 5, and I get 10. Okay, listening. What did I actually just find? I just found f of 1, didn't I? If I can just plug it directly in, did I not just find f of 1? If I can plug it directly in and there is no problems, that means that at that x value, this graph is continuous. Right? Because what is this telling me? This is telling me if I plug it directly in, f of 1, the answer to 1 is 10. So on this graph of 2x, bracket x plus 4, I have a coordinate at 1 and 10 because I plugged it in and it worked. It also tells me from the left and from the right of 1, it's approaching 10. We agree? So if you can plug in your value right off the bat, it doesn't cause problems. That means that that graph is continuous at that coordinate. From the left, from the right, it's approaching the same thing. At that value, it's the same thing. Does it mean that that graph is continuous everywhere? If I just plug in 1 and it works, does that mean everywhere it's continuous?
No.
No. However, if I distribute that in, I know it's 2x squared plus 8x. It's a quadratic, and quadratics are what? Continuous everywhere, right? So my knowledge of 30-1 and 20-1 tells me I know that this graph is continuous everywhere, and I can just plug it in, right? Okay, let's look at this one. It's 2 from the right. It's 2 from the right. The 2 from the right or 2 from the left change if I can just plug it in? No. So if you can just plug it in, your 2 from the right is going to be the same answer as your 2 from the left. It's going to be the same answer as your 2. Because it's a continuous function. Okay? So let's plug in the 2 and see if it causes this problem. It's a quadratic, it's not going to. I just ruined your thing. So we get 4 times 2, 2 minus 2. So I get 8 times 0, which is 0. Now some people will say, well, that's a problem. It's not a problem unless you're dividing by 0. Am I dividing by 0? No. This means at this graph, 4x times 2x minus 2 minus x, which is the same as 8x minus 4x squared, which is a quadratic. At 2, I have 0. So from the right, it's going to approach 0. Okay? Note, the limit properties are also true for one-sided limits. So we are in section 1.2, I believe. Was it 1.2 at the beginning of the notes? So you're in your textbook. You're going to try problem 13 quickly. That doesn't say AP, that says 13. So to find the limit of piecewise defined functions at numbers where the defining equation changes requires the use of one-sided limits. So remember, the limit L of a function y equals f of x as x approaches a number c exists if and only if from the left and the right your limit is the same. That's what that's saying. So the limit at c only exists if left and right are the same. You could have a left limit that's different than a right limit, and then you have a left limit and a right limit, but you will not have a limit at that value. They need to be the same in order for it to be the same. Okay? So we need to find out if the limit is x approaches 2 of f of x if it exists. Okay? So we are going to draw the graphs first. We're going to talk about this. So I'm going to give myself some lines here. All right. We're going to try it quietly. We're going to see if we can do it with our mouths closed. It's going to be a test. It's not working. It is. Still not working though. Nice. All right. Remember that you have to be able to draw your graph from scratch. Remember that you put arrows on your axes, show that it's continuously going onwards. And you have to label them so that the person who is marking your work knows what the heck you made each little tick be. So I'm going to say X scale of 1. And I'm going to say y scale of 1. Now, we need to make a table of values that covers the one equation and a table of values that covers the other equation. If you do not pay attention, you will never be able to draw one-sided limit questions, and then you'll do bad graphs, and then it'll be bad for the test. This is where I lose people, okay? We have to be able to do these graphically. We have to be able to do these numerically. We have to be able to do these algebraically. So we're going through all the different ways. First one we're going to do is graphically. I have to be able to sketch the graph of 3x plus 1 when x is less than 2, okay? So it's going to go right up to 2, but it's not going to include it. So some people are like, well, I'm going to use 1.99. No, you're going to use 2, and then you're going to open dot it. That's all you're going to do. So you still edge right up to the table. So I'm going to do the first one, x, and then this, my y is 3x plus 1. I don't write y. I'm going to write 3x plus 1 instead of y because I'm finding it out. All right, you guys are distracting. You got to stop. So I start at my restricted domain. X is less than 2. So where am I going to start at? 2. And then I'm going to pick values less. It's not crazy, I know, but that's what we're going to do. So we're going to plug in 2. I'm going to get 3 times 2. Don't know how that just changed. Felt like it wanted to. It tries to read my mind. So it's 7. So I know at 2 and 7 I have a coordinate. It is going to be an open dot. So I go to 2, and then 1, 2, 3, 4, 5, 6, 7. And I'm going to put an open dot. Then I'm going to pick a value less than it. So I'm going to pick 1. Then I go 3 times 1 plus 1, and I get 4. So now I have 1 and 4. And I have a closed dot for it. Then I could pick 0. 3 times 0 plus 1 is 1, which makes sense because it's 3x plus 1, so it has a y-intercept at 1. All right? Now, it is a line. I could use slope to find the rest of it. It's up 3, right 1, or the complete opposite, down 3, 1, 2, 3, left 1, down 3, 1, 2, 3, left 1, down 3, 1, 2, 3, left 1. And I have, on a piece of paper, a perfectly straight line. So on the left, that is what my graph is looking like. We agree? Now we have to use a new table to do the right-hand side. Our right-hand side of our graph comes from our x values, and our y is now going to be 2x, x minus 1. And they don't have to be 2 and 2. It could be like 2 and the next one starts at 3 and there's a big old gap in the graph, right? This one is 2 and 2. The catch with this 2, I'm going to start at 2 because it says x has to be greater than or equal to 2. My restricted domain starts at 2. The catch with this one is what? It's a closed dot because there's an equal to sign. So I'm going to plug in the 2, and I'm going to get 2 times 2, and then 2 minus 1. So it's going to be 4 times 1, which is 4. So now I have 2, 4, closed dot. And that's the start of my right-hand side of this graph. Then I'm going to plug in 3. So I get 2 times 3, and then 3 minus 1. So I'm going to get 6 times 2, which is, oh, that really jumped. I think I ran out of space. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I would be resketching this if this was a test. Why would I resketch this if this is a test? You want to put the most coordinates on, and I just drew a coordinate that's not even on the graph. It's literally hovering above the box. You should not do that. Now this, if you don't know how to sketch the graph, look at the graph. It is 2x times x minus 1, which is 2x squared minus 2x, which is a quadratic, correct? So this is part of a quadratic graph. So it's going, okay, this is supposed to be blue. It's going up and This is my notes, I'm leaving it. If this was a test, I would never leave a coordinate. First off, my only other coordinate is off the graph completely. That is stupid, okay? I will not do that. I would resketch this and make my y scale, either make them smaller or make my y scale bigger, yeah?
It's supposed to be straight or curved?
Well, it's going to be a bit curved because it's a quadratic graph, right? It's not going to be substantially curved, but a bit curved because it's quadratic. All right. So, the limit as x approaches 2. What would I say? Doesn't exist. Why, Jonah?
Because the left and right-handed limits are different.
Left and right-handed limits are different. The left is approaching 7. The right is approaching 4. Do you see that? So I would say the limit as x approaches 2 from the left of f of x equals 7, based off of this. The limit as x approaches 2 from the right of f of x equals 4. So the limit as x approaches 2 of f of x does not exist. Now, do I have to sketch a graph every single time to do this? No. What could I have done? I could have done it algebraically. If I want, I'm going to do a little erasey down here. Okay. Caca. Okay. If I want the limit as x approaches 2 from the left, and it's a piecewise function, I'm not going to write f of x here. What equation is from the left? 3x plus 1. It's the less than 1, correct? So I go limit as x approaches 2 from the left of 3x plus 1, and then I can plug it in, can I not? So I would get equal sign. Limit goes away because I'm going to plug it in. 3 times 2 plus 1, and I get 7. So I can just algebraically do it, unless they force me to a graph. Then I do the limit as x approaches 2 from the right. Now I have to pick the greater than function. So instead of putting the f of x, I go 2x, x minus 1, and then I can plug it in. So I get 2 times 2 times 2 minus 1, which is 2 times 2 times 4. It was up there. I don't know how I just halted there for a second, my brain quit. All right. These are the questions you're going to try. 75, 77, 79. AP practice 1 and 5, which is the green section. Correct? Giving you about 5.